Hi, this video is on finding asymptotes of rational functions. So when we look for vertical asymptotes, what we do is we look for values that make the denominator 0. If no such value exists, then there are no vertical asymptotes. But then if you do have values like that, then you're going to substitute values in the numerator. If the numerator is not 0, then you're going to have a vertical asymptote there. Otherwise it's a whole. To find a horizontal asymptote, if the degree of the numerator is less than the degree of the denominator, so the degree on top is less than the degree on the bottom, then it's going to be 0, y equals 0, a horizontal line. If the degree of the numerator is equal to the degree of the denominator, then it's going to be the ratio of the leading coefficients of the two polynomials. And if the degree of the numerator is greater than the degree of the denominator, then no horizontal asymptote. However, if the degree on top is exactly 1 greater than the degree of the denominator, then it's going to have a slant or an oblique asymptote. And you divide one polynomial by the other and you look for the quotient. Some things you need to know. A rational function may not have any asymptotes. It does not have to have any asymptotes at all. If applicable, rational functions may have a finite number of vertical asymptotes. In other words, you have 2, 3. It's possible to have multiple, but it's going to be a finite number. Rational functions can have at most one horizontal asymptote, and it cannot have both slant and horizontal asymptote. Right, let's take a look at some problems. So find the horizontal asymptotes here. In this case, we're just gonna look at the denominator, so we know x cannot equal 1, right? But what happens at 1? When x equals 1, the numerator is not 0, the numerator cannot be 0 anyway, so that means that x equals 1, it's a horizontal asymptote, vertical asymptote. So we have a vertical asymptote, x equals 1. What about a horizontal asymptote? The degree on top is actually 0, the degree on the bottom is 1, the degree on top is lower than the degree on the bottom. We have a horizontal asymptote here. Y equals 0. Example 2. So what do we have here? The denominator is going to be 0 when x equals -1. So we know x cannot equal -1. What happens at -1? The denominator is 0, the numerator is not. We have a vertical asymptote. X equals -1. What about a horizontal asymptote? We have the same degree on top and the bottom, above degree 1. So we divide the leading coefficients. Is going to be what, 2 over 1, so which is 2. This example here, so we need to be careful. This is a very common mistake. If I factor this, it's 3 times x plus 3 divided by x minus 3 times x plus 3. Okay, so we know the values of x cannot be plus or minus 3, but at -3, both the denominator and the numerator will be 0. So x equals -3 does not give you a vertical asymptote. You're only going to have one vertical asymptote here at 3, because when x equals 3, the numerator is not 0. So for our vertical asymptote, we have x equals 3. Again, remember, for a vertical asymptote, the denominator must be 0 and the numerator cannot equal 0, any other number. What about a horizontal asymptote? For a horizontal asymptote, what we have here is the degree on top is less than the degree on the bottom. It's going to be y equals 0. This next problem. It's always a good idea to factor, just to see what's going to happen, in case if you have common factors on top and the bottom. So when x equals 2, we know x cannot equal 2. And the numerator when x is equals to is not 0, so we have a vertical asymptote at 2. X equals 2. Do we have a horizontal asymptote here? Yes, we do. The degrees are the same. And that means we are going to divide the leading coefficients. And when we divide the leading coefficients, it's actually going to be 1x squared on top and 1x squared on the bottom. So it's just going to be y equals 1. This next function, so we do need to factor, if possible. X minus 3 times x plus 2, right? So we have two values that x cannot equal that will make the denominator 0. That's 3 and negative 2. Are they both vertical asymptotes? Not negative 2. For negative 2 you're going to get 0 on top and 0 on the bottom because of these two factors. So that's not a vertical asymptote. That's actually a very common mistake, because often students just look at the denominator, find the zeros of the denominator and just go with them as vertical asymptotes. That you always have to check the numerator as well. So negative 2 here is not going to give you a vertical asymptote, but 3 will. So we have a vertical asymptote which is going to be x equals 3. Do we have a horizontal asymptote here? Well, the numerator has degree 2, the denominator has degree 2. So for our horizontal asymptote, we have y equals the ratio of the leading coefficient 1 over 1, which is 1. This next problem, we got this function where the degree of the numerator is 2 and degree of the denominator is 2, but before we get to that, let's see if we can factor it. The numerator cannot be factored. The denominator can be factored as x plus 2 times x plus 1. So that means x cannot equal negative 2 and negative 1. And for these two values, the numerator is not going to equal 0. As a matter of this, numerator cannot equal 0 for any value of x. And that means that both of these numbers are going to be our vertical asymptotes. So we're going to have 2. So we have x equals negative 2 and x equals negative 1. What about a horizontal asymptote? Same degree. So we're going to have horizontal asymptotes here. Well, horizontal asymptote. A horizontal asymptote will be the ratio of the leading coefficients, since the degrees are the same. It's going to be y equals 3. Okay, this next function, we have, can we factor it? The numerator, you can factor out 2 first. The denominator does not factor at all. And then you can continue. But this is actually not anything you need to do, because we are only interested in the values that make the denominator equal 0. So x can be any real number. That means you have no vertical asymptotes. No vertical asymptotes. Do we have a horizontal asymptote? Well, the degree of the numerator is 2, the degree of the denominator is 2, same degree. We have a vertical asymptote, which is going to be y equals ratio of the leading coefficients, that's 2. Alright. Next problem. So what we need to do is divide this and see what's happening. we are going to need to try to factor the numerator. Does it factor? We don't, no it does not. So it's going to stay like that. So we have, we know that x cannot equal -1. So what happens at -1? The numerator is not going to equal 0 when x is -1. So we have a vertical asymptote x equals -1. And this is that situation when the degree of the numerator is going to be higher than the degree of the denominator. So first of all, we have no horizontal asymptote. Horizontal asymptote. But the degree of the numerator is exactly 1 higher than the degree of the denominator, which means we have a slant asymptote. This is a linear binomial, so I can use synthetic division. I'm going to take -1, 1, 4, -5. You can use long division too if you want, but I'm using synthetic division. I just want to know what the quotient is going to be. So it's going to be 1, it's going to be -1, it's going to be 3, it's going to be -3, and it's going to be 8. This is the remainder, but it's irrelevant. You went from quadratic to linear. This is 1x plus 3. And that is the equation of our slant or oblique asymptote. So slant asymptote here is going to be y equals x plus 3. Alright. So moving on. This next problem. Example 9, x cannot equal -1, right? So what happens at -1, the denominator is 0, the numerator is not, we have a vertical asymptote. X equals -1. The degree on top is higher, so no horizontal asymptote. What about the slant asymptote? Well, you're dividing, you have a degree of the numerator is 1 higher than the degree of the denominator. And I can use synthetic division again. 2, 0, 1. So 2 comes down, 2, it's going to be 2, 2, and 3. This number is our remainder, which we don't care what it is for these problems. What we want here is this is 2x plus 2, because you went from degree 2 to degree 1. And we're going to have a slant asymptote. Which is going to be y equals 2x plus 2. Okay. This next problem, well, I'm not going to factor the numerator, it's a little awkward. It's not going to factor easily with integers, but we will factor the denominator, it'll still do the job here. So we know x cannot equal 3 and -3. For both of these values, the numerator will not equal 0. That means you have two vertical asymptotes. It's going to be x equals 3 and x equals -3. The degree on top and the degree on the bottom are the same. So we have a horizontal asymptote. It's going to be the ratio of the leading coefficient, same degree, so y equals 3 over 1 or 3 divided by 1 here. Okay, I think we have a couple more examples. Okay, so over here we could factor the numerator, but it's not necessary. We factor the denominator and we know x cannot equal 1. When x is 1, the numerator clearly is not 0, so we have a vertical asymptote at x equals 1. Do we have a horizontal asymptote here? No, because the degree on top is higher, so no horizontal asymptote. Do we have a slant asymptote? No, we don't, because the degree on top is more than 1 higher. See, the degree on top is 3, degree on the bottom is 1, so we have no slant asymptote either. By the way, the term slant asymptote and oblique asymptote are actually, it's the same term. Some textbooks use oblique, some use slant. Okay, this last problem here. So if we factor the denominator, we're going to get x minus 1 times x plus 1, right? And that is going to give us two values that we cannot use for x, that x cannot equal plus or minus 1. So what's going to happen with each one of these 2 points? Well, when x is 1 or negative 1, the numerator will not be 0. That means we have vertical asymptotes. 2 of them. One of them is going to be x equals 1, the other one is x equals negative 1. What about a horizontal asymptote? The degree on top is higher, no horizontal asymptote. Okay. What about a slant asymptote? Well, here we have a function on top which is cubic and a function on the bottom which is quadratic, so the degree on top is 1 higher than the degree on the bottom. We're going to have to divide, but we can use synthetic division because this is not a linear binomial, so we're going to use long division. So we're going to put x squared minus 1, and here we're going to put x cubed plus 4, and I hope you're somewhat familiar with long division of polynomials. We obviously need x here. To multiply x squared to get x cubed, you need x, so x times x squared is x cubed, x times negative 1 is minus x. We subtract them, x cubed minus x cubed gives you 0. Here what we're going to get is you are going to get 0x minus negative x, so it's going to give you x, and then plus 4. This is our remainder, but this remainder is no longer important because x squared minus 1 does not go into that. So that's going to stay the remainder here. And what we have on top is the quotient, and our slant asymptote here is going to be y equals x. This is our quotient on top, so y equals x. And I hope this was helpful.